Hello students, today we are going to study the cross-Cannizzaro reactions. Cross-Cannizzaro reactions itself indicates that it is the types of Cannizzaro reactions, only change in the some reactants. Means in Cannizzaro reactions we use the same molecules of aldehydes having the no alpha hydrogen atoms. But in case of cross-Cannizzaro reactions we use the mixture of two aromatic aldehydes having no alpha hydrogen, means not same types of aromatic aldehyde. We are using aromatic aldehyde having no alpha hydrogen atom reacts with the strong alkali. In Cannizzaro reactions we are also using the strong alkali. In these cases we are also using the strong alkali. The mixture of acid and alcohol is obtained, and this is called as cross-Cannizzaro reactions. Here are the examples. Examples are given: two molecules, aromatic aldehydes, one aromatic aldehyde, another aromatic aldehyde, 1, 2, cross, means two different type of, means it is a mixture of two different types of aromatic aldehydes in presence of strong alkali base, that is NaOH. Then we will get the acid, another one is the one, we will get the one acid, another one is the alcohol. Okay, and depending which form the acid and which form the base is the conceptual. How it is conceptual? It is conceptual means which, here is the 2-carbonyl, 1, 2 carbonyl carbons. So firstly we have to decide which carbonyl carbon will be act as the nucleophile and which carbonyl carbon act as the electrophile. Okay, so electrophilic center will be those center which is more electron deficient, means here is this compound. In this case already having the carbonyl carbon, means electron deficient, but this is a electron withdrawing group. This electron withdrawing group makes this carbonyl carbon is more electron deficient, and another one is the aldehyde groups which is less electron deficient. That's why first attack will be takes place on this group, means OH attack on this. Here is hydrogen removes, this hydrogen attack on this. We will get here the alcohol. In this case we will get the sodium salt of carboxylic acid. Example here is also, in this case also aldehyde, this aldehyde become aldehyde and this is the aldehyde, but in this case this aldehyde is more electron deficient, means OH attack on this, it will give the acid, sodium salt of carboxylic acid, and this electron deficient, means it will get the hydrogen H- ion hydride and converted into the acid. Next one is the ketoenol tautomerism. In ketoenol tautomerism is the phenomena by which two or more constitutional isomers of a compound Differing in the position, monovalent atoms are in rapid equilibrium with each other. Tautomerism is the phenomenon by which two or more constitutional isomers of a compound differing in the position of monovalent atom are rapid in equilibrium with each other. Keto-enol tautomerism. Mechanism of enolization. Oxygen atom in presence of acid. CS3C double bond OH CS3BH first. This is followed by the removal of the alpha hydrogen atoms from conjugated acid by very weak base H2ROH. We will get the conversion of keto form into the enol form. Next one is the base catalyzed enolization. Proton first removed from the alpha carbon atoms of a carbonyl compounds. In this case, the bases act and abstract the proton and convert it into the enolic form CS2 double bond CO minus BH. Then the proton is transferred to oxygen of enolate ion by conjugate base. This is the CS3COH double bond CS2. We will get the final compounds enol in all. So this is the keto-enol tautomerism. Why need of keto-enol tautomerism? Because in case of some ketone, keto-enol tautomerism is possible because ketone and enol both are the isomers. Both are having the same number of carbon atoms, same number of hydrogen atoms. Only difference is that keto form is the ketonic functional group and enol form is the alcoholic functional group. Means a big difference in the functional groups. But which functional group exists, that depends upon the stability of that group. Generally, what happens, the enolic form is more stable, but the tautomerism form is continuously converting from keto form to enolic form and enol form to the ketonic form. But for the conversion, there are acid can be used and base also used. Means acid catalyzed enolization is possible as well as the base catalyzed enolization is also possible. So by using these methods we can remove. The next one is the active methylene compounds. Active methylene compounds are the compounds in which methylene group, that is CS2, is attached to the two electron withdrawing groups like C double bond C, C triple bond C, NO2. Electron withdrawing group apply the inductive effect and the hydrogen atom of the methylene group is activated and having the fractional positive charge. Hence, this carbon atom easily remove the hydrogen atom in presence of base. Here is the example how electrons are removed by the active methylene group. He explained that this is the active methylene group, means it having the two hydrogen atoms and the carbon to which two carbon hydrogen atom attached, that carbon attached with the two carbonyl carbon, means electron deficiency is more. Means if you remove, it is the alpha hydrogen atoms, it easily we can remove easily by using the base and acidity. This anion is stabilized. This negative charge is stabilized by these two carbonyl carbon, means a stable carbon anion. So that's why it is the active methylene group is most important. We have the best examples are given here. It is also active methylene compound CS2 attached with two carbonyl carbon, means alpha positions hydrogen atoms are more acidic, it can easily absorb. It is also CS2 alpha hydrogen with active methylene group, it is also active methylene group. Preparation of higher ketones. We will discuss this topic in the next lecture. Thank you. Allah.